Hello, we should continue. We start by resolving the exercise of chapter 2. I hope that you did them yourself. So let's see together what's the result. So the first exercise is to encrypt the plain text computer using the generalized Caesar cipher with key equal 5. So I hope that you did. It's a very simple uh, exercise. So because it's computer, so we have to take each letter apart, and the ciphertext will be the encryption of the plain text and with key equal 5. So it will be 5 text B, and it will be equal to B plus 5 modulo 26. So if I want to take C, remember that C is 2. Okay, C is 2. So the letter C is 2. So we have to put the number of each letter from 0 to 25 and to apply it. So for C, let's take the letter C. C equal, as we said, 2. So it will be 2 plus 5 or 20 is equal 7. And in this case, the letter is H. So you should apply in the similar way for O, for M, for P, for U, for T, for E, for R, and so on. And the result will be H, T, R, U, Z, Y, G, W. Okay, this is the result of uh, exercise 1. You should apply it, please, to be sure that you are able to apply. If you want to decrypt, for example, you know that the decryption, if you want to go from H to C, the decryption is very simple. It's just to take the ciphertext minus the key modulo 26. Okay, let's move to exercise 2. You have intercepted the following encrypted message. So we have E, it's an encrypted, so it's E, R, B, C, W, M, W. And you know it was encrypted using Caesar cipher. So we know the algorithm. Okay. So in this case, we try to find the plain text. So the idea here is, as we said, we want to take the relative frequency, the relative frequency of the letters, and to see which letter is the frequent one. Okay. Or we have to make a brute force attack. So to find the plain text equal the ciphertext minus the key mod 26. Okay, if you want to apply brute force attack, we have to take all value of k from k equal 0, 0, it will be the same. So from k equal 1 to 25, and one of them will give the good result. Other way to do is to uh, take the most frequent letter. Okay, see also take the frequency of letter. Okay, so I will maybe you can try this. It's interesting for you to know the result. Okay, uh, you can ask me if you didn't find the result, but it's very easy. Okay, both it's possible to be done. Okay. Uh, for the exercise 3, it's a kind of generalization of Caesar cipher. We call it affine Caesar cipher, and it has the following form. So for each plain text P, substitute P by a ciphertext C, where C equal A, B, A plus B modulo 26. Okay, so we multiply the plain text by A, then we add B. So, and after that, we apply modulo 26. So a basic requirement of any encryption is that to be one-to-one. This is one of the important characteristic because for each plain text we in substitution based on the algorithm we should have only one ciphertext, and for each ciphertext if we want to decrypt it we will have only one plain text. So that's why the characteristic of one-to-one is very important. So if P different from Q, then EP, this is just the explanation. If we encrypt using the same key, a plain text P and a plain text Q, this means that the encrypted text of P should be different from the encrypted text of Q. Otherwise, the decryption is impossible because more than one plain text characters maps into the same ciphertext. It's very clear. In case that we have more than plain text that results in the same ciphertext, if you want to decrypt, it will be impossible to know which one. So that's why the relation should be one-to-one. Okay, so we start here for A equal 2 and B equal 3, and we want to find the ciphertext of 0 and the ciphertext of 13. So let's start with 0. So as we said, A equal 2, B equal 3, so the ciphertext is equal to plain text plus 3 mod 26. Okay. For the plain text equal 0, the ciphertext is equal to times 0 plus 3, it's equal 3. Okay, it's equal 3, it's 0 plus 3 mod 26, it's equal 3, which means in this case that it's the letter 3 is D. Okay, so it's D. If we have a plain text 30, okay, this is one of the letters, so in this case if P equal 30, the letter 0 is A. Okay, 30 is we can find it on the course slide. So the ciphertext here C equal 2 times 30 plus 3, which is equal to uh, 26 plus 3 mod 26, which is also equal to D, and it's the letter D. So here in this example we have two different plain text, but we obtain the same ciphertext. Okay, so that's why we have the second question: is it possible to decrypt the cipher given in part A? It's very easy to say that decryption here is impossible, as we said. Okay, decryption is impossible because more than one plain text character maps into the same ciphertext. Okay, because we don't have one-to-one relation. We don't have one-to-one. Okay, that's why it's not possible to decrypt, because here we have the ciphertext 3 and we want to see what's the plain text. We have more than one plain text, also which one we should select. That's why it's impossible. This is the part B. So for the part B, as we said, the decryption is impossible because we have more than one plain text character maps into the same ciphertext characters, and it's not one-to-one characteristic or one-to-one mapping. For the part C, is F and Cesar one-to-one for all value of A? Here is uh, uh, is a general question. Okay, we say that C equal A B plus B mod 26. For which value of A generally it's one-to-one relationship. As we said, if we put A equal 1, if we put A equal 1, it will be okay. For example, in this case, it will be P plus B, and in this case, we will have one-to-one relationship. However, for example, for other values like 2, like for example, here we used A equal 2, for example, it was not one-to-one. So maybe I will ask you to try to see what are the other values of A that are not one-to-one mapping, okay? So here just I give you an example for A equal to, okay, is not one-to-one. So the result is that uh, Caesar cipher here is not one-to-one for all value of A. We can find, for example, for A equal to, it's not, or for here as here is for A equal to, this cipher is not one to one. Okay, as we said, for A equal 1, it's one-to-one cipher. Okay, but for A equal to not. So you can also try to check you by yourself for what are the other values of A that's not one-to-one. Okay. For D, is there any limitation on the value of B? Okay. Is there any limitation on the value of B? Because we are adding B. We are adding B. Okay. Uh, it's just any value. So B could be any value between 0 and 25, because we are working on 26 letters. So any modification of B, it's just a sample shift. Okay, it's just a sample shift of the relation, and typically in this case the mapping is one-to-one. So regarding B, we have one-to-one for all values between 0 and 25. So that's why for B we don't have any limitation. Okay, it's just because we are working between 0 and between 0 and 25. Okay. So finally, a ciphertext has been generated with an Affine cipher. So we used an Affine cipher here. So the most frequent letter of the cipher is B. So here we have a generated, and we know that in this ciphertext, the most letter is B. And the second most letter is U. Is it possible for you to break this code? We have to check on the if you remember in the course, we see what could be the most frequent letter. Okay, what could be the most frequent letter, and what's the second most frequent letter, and based on we can detect what's the value of A and B. In order to break this system, we have to find what's the value of A and what's the value of B, and in this case we are able to decrypt any message encrypted using this ciphertext. So let's see together the most frequent letter on the second, just to switch to the value. Okay. So remember that based on the frequency of letter A, okay. So I will stop share here and I will check with you. If you can see on this, okay, we can see that the most frequent letter is E, and the second one is T. Okay, T here. So that's why E is typically equal to 0, 1, 2, 3. It's 5, and T is uh, 5, 6, 7, 8, 9. It's 19. Okay. So let's move to. So based on the frequency letter, it's possible now to say that I expect that based on the frequency analysis, I expect that sorry, E, so E will be B and T will be U. So E is equal to, the number of E is 4 and B is equal 1. So the first relationship will be, the result is B, so 1 will be equal to A times 4, or 4A plus B mod 26. And the second, remember that T is 19 and U is 20. So 20 is equal A times 19 plus B mod 26. So that's why we have to resolve uh, this system. So it's possible to do it. We can subtract using modulo. It's possible. So if we subtract this one, so we obtain 20 minus 1 is equal to 19, equal here it's equal 15 A modulo. So here we have to find what's the value of A that's mapped this one. So we start with A equal 1. It's not possible with A equal to 30. No, it's A equal 3. 45 mod 26 it will be okay. So for A equal 3. And after that we apply for one of them. Okay, for A equal 3, let's say 12, plus which value of B it's equal 12 modulo 1, it will be 15, so B equal 15. So in this case, we break the system and we are able to recover any value provided by this system. Okay. If you have any question, just you can send me a message or we can have a specific discussion online. Okay. Let's move to exercise 4. Here we want to apply encrypt the plain text computer using Playfair cipher with the key monarchy. Remember that using monarchy, we did this during the course explanation. So the idea is to have the secret key. So to put mo, it's 525. Nar, okay, monarchy. And after that we have to continue. So A, B, C already done, D, E, F, G. Remember that I and J should be the one letter only. K, L, M, N, O, R, Q, L, M, N, O, P, Q, R is here, S, T, U, V, W, X, Y is already here, and Z. So we want to to encrypt, so we have to consider the plain text computer okay, because here we are working with two letters together with ciphertext. So the idea here is that the first one will indicate the line. So for C, it will be like this. So it will be the same row. And for O, it will give us the columns. And the result of the ciphertext of the plain text C will be H. For O, it will be the reverse. For O, it will be the same row, and C will give the columns, and it will be M. Okay, so the encryption of CO is HM. Now for MP, remember that for MP, because they are M, okay, and P. Where is P? Here is P. So M the same line, P the same column, it will be O. And the other one will be L, and so on. You can continue following the same approach. Okay. For exercise 5, using the Vigenère cipher, you should encrypt the plain text using the key leg. Remember that using Vigenère, we have a key, and for each letter we should encrypt. So in this case, if we have explanation X, we should have, as we said, a key for each letter, and typically the key is leg, so we have to put leg, 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 LE. So in this case, we should apply the ciphertext for L. Okay, so this is the plain text, this is the key, and we should obtain the ciphertext. So for this one, we should take E and L. Okay, and after that we find the ciphertext. So the ciphertext of E, remember that it's 4, and we have to add the value of L. In this case, the value of L, it's around, I want just to check it on the slide. Okay, the value of L is so the value of L is 11. So it will be 4, sorry, it will be 4 plus 11 mod 26, it will be 15 mod multi-6. That 15 will give us the letter P. Okay, so it will be P. Now for X, okay, I want to check also X, and the key here is also E. So the ciphertext is X. X is 23. X is 23 plus the the key is E, which is 4 mod 26, which is equal to 27 mod 26, which is equal to 1. 1 is the letter B. And so on. You have to continue following the same approach. Okay. Let's continue with exercise 6. So this problem explore the use of one-time pad version of the Vigenère cipher. So in this scheme, the key is a stream of random number. We will explain in the next chapter the stream cipher, and we will see what's the stream cipher. So here we have a stream of the key is a kind of stream of random number between 0 and 26. So for example, if the key is 3195, then the first letter of plain text is encrypted with a shift of 3 letters, the second with a shift of 19, and the third with a shift of 5, and so on. So we should encrypt the plain text send more money with the following key. So the idea here is that we should put as we did together in Vigenère, it's the same but it's the longer one. So we have to put send more money. Okay, and we have the 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 key is 9, 0, 1, 7, 23, 15, 21, 14, 11, 11, 2, 8, 9, and we have to put the value of each letter. So remember, I want just to check on the slide, so it will be 18, 4. So this is the plain text. This is the plain text. 4, 13, 3, 12. O is 14. R is 17. E is 4. M is 12. O is 14. N is 13. And E is 4. And Y is 24. So here, after doing that, we should apply for each of them. So the ciphertext will be this value plus this value mod 26. So, okay, it's 9. Yes, it's 9. The key here is 9. So 9 plus 18, it will be 27. 27 mod 26 is equal to 1, and the letter 1 is B. Here 0 plus 4, 0 plus 4 is equal to 4, which is the letter E. And so on, we can continue like this. 13 plus 1 mod 26 is 14, and 14 is the letter O. And so on, we can continue the same. So using the ciphertext produced in part A, find the key so that the ciphertext decrypt to the plain text cache not needed. So here you should decrypt, okay, having okay, you have a ciphertext and you have a plain text, okay. So you should find the key that's possible to cipher. So you know the plain text and the ciphertext, and you should find the key. So it's something that we did several times, so maybe you can try to find what's the key. It's okay. And in this case, it will be for each letter. Okay. And here we have another exercise to see the importance of the distribution of the ciphertext. Here we consider a crypto system with the plain text XYZ and the different key that we have K1, K2, K3, and the ciphertext space, which is A and B and C. It's a simple example. We applied here only for 3 values in each case, but it's just to let you understand the main characteristic of distribution of the uniform distribution. So here we give the probability distribution of the probability to have a certain y, or probability to have the key to be defined as follows. In our space of plain text, the probability of the letter x is 3 over 8, the probability of y is 1 over 8, and the probability of z is 1 over 2. However, for the key space, we have the probability of key 1 is 1 over 3, the probability of key 2 is 1 over 6, and the probability of key 3 is 1 over 2. And here we have together the encryption function. This means that if we encrypt x, the plain text x, with the key key1, we have the ciphertext A. If we encrypt the plain text x with the key key2, we have the ciphertext B. If we encrypt the plain text x with the key key3, we obtain the ciphertext C. And so on for y. If we encrypt y with the key K1, we have the ciphertext B. If we encrypt the plain text Z with the key, for example, key 3, we have the K3, we have the ciphertext B. So the first question is to find the probability distribution of the ciphertext equal A. So as you know, when we obtain the ciphertext, okay, the probability to have the ciphertext equal A, it will be here and here and here. From those cases, we obtain the probability of a ciphertext A. So it's the probability that, in this case, the probability to have the key equal key1, and we should have the plain text equal x. Okay? Plus the other case is to have the key equal k3 and the plain text equal y. And the third case is we add, because this is it's possible to have all those possibilities, the key equal k2 and the plain text equal z equal z. So this is simultaneously, so in this case it's the multiplication of it. So the probability to have k equal k1 and p equal x is the probability to have k equal k1 times the probability to p equal x, and in this case it will be, as we said, 1 over 3 times 3 over 8 plus k equal 3, in this case 1 over 2 times 1 over 8 plus 1 over 6 times the probability of p equal y, sorry, the probability of p equal z is 1 over 2. So after calculating them, it will be 13 over 42. Okay. So here we find the probability of ciphertext equal A. For ciphertext equal B, we should follow the same, but in this case, we should, this case, and this case, you should make all calculation, and I did it, and the result is 70 over 48. And for the probability of the ciphertext equal C, should take this case, and this case, and I did all calculation, and it's equal to 3 over 8. So this is the probability distribution of the ciphertext. So the question is the proposed system perfectly secure and provide your reasoning? Just to give you of one of the main characteristics to have a good and a secure crypto system is to have what we call uniform distribution among the ciphertext distribution, ciphertext. So in this case, in this case, we don't have a uniform distribution because the probability to have a ciphertext of type B is bigger than the one of type A and the one of the type C, and it's not a uniform distribution. So that's why this system does not provide perfect security. So it's not a perfectly secure system. To be like this, we should have the probability of C equal A equal 1 over 3 equal probability of C equal B and equal probability of C equal C. So all of them we should be 1 over 3. Okay, all of them we should be 1 over 3. So that's why uh, uh, it's not a perfect system. Okay. Um, I want just to check because here maybe I have some error. I should check because the sum here should be equal to 1. It's not the case. I want to repeat the calculation just 1 second. Just here to be sure that here is it's okay because here it's 3 over 8. It's okay. It's fine. So here the third one is 3 over 8. Okay, so it's fine. Okay, so the answer in this case is that we don't have a uniform distribution among the ciphertexts, so this system doesn't provide perfect security. Okay, so this will end the exercise of this chapter, and we move to the next chapter. Okay, so we will start with data encryption standard.